The idea of supply chain risk management has become increasingly popular as something we discuss these days. One of the advantages we have is that there is a number of really good standards that can help guide us through the process of risk management in regards to the supply chain. From NIST, we have the special publication 800-161 Revision 1, which is entitled Cybersecurity Supply Chain Risk Management Practices for Systems and Organizations. And then we have the IR 8276 that lists for us key practices in cyber supply chain risk management, observations from industry. We have, in addition, very good ISO standards. The ISO 27000 series includes the 27236, which is cybersecurity supplier relationships. Part 3, guidelines for hardware, software, and services supply chain security. And this is closely related to also the ISO 27001 and the 15288 documents. The idea of security of third-party software starts with making sure that the third party actually develops things in a secure development environment. We saw, for example, through Petya, an example of malware being implanted right during the development process. And we've seen that in a number of cases where hackers broke in and were able to infect software while it was being developed. Now, that shouldn't happen. Proper quality control and testing of the software should have revealed that undocumented functionality, or at least increase the likelihood of seeing it. It is difficult to reduce the risk to zero, but having a secure development environment is a start. The next thing, of course, is to have a trusted distribution system, so we don't have any problem where maybe an infected version is being pushed out instead of the patch or the version of software we wanted. So this is where we use things like digital signatures to create what we could call a digital shrink wrap that would immediately indicate if there's any tampering. We've seen the problem lately, though, that this does not work perfectly either. We've just seen, as I'm recording this now, the problem of Microsoft's private keys having been stolen, and we've seen this with a number of organizations who have become victims of this. Stuxnet also, the writers of Stuxnet, were able then to steal private keys from several software development houses so that that patch looked like it was legitimate. So in the end, digital shrink wrap only works as well as our protection of the cryptographic keys used to protect that software. We need to know, how does a vendor respond when a vulnerability is found? We used to see this where vendors would get angry that somebody disclosed the vulnerability and said, "You're hacking our system." And that would lead up to this debate about, well, since vendors don't want to fix these things, all they want to do is blame the people that find it, that we needed to go to full disclosure to almost embarrass or force vendors to fix their problems. Many vendors have gotten better about that, especially with things like bug bounties. But we need to know that if a vendor is aware of a problem, do they take it seriously? Or are they just accepting the risk, or are they mitigating the risk? Can we mitigate it through putting in barriers or protective layers, such as defense in depth? Or in some cases, if we know there's a vulnerability and it's going to take a little while for the vendor to actually release a patch, we could increase our monitoring to see if there's been any problem. In other cases, we've seen where actual rules have come down and said, you must disable that software immediately. We have to avoid the risk. It's too risky to use it. Key points review. Unfortunately, many organizations have been victims of vulnerabilities in third-party software related to networks, network equipment, cloud and cloud-based software, and other types of integrated systems and operational technologies. We know that organizations are often a victim of software vulnerabilities, though, that had already been known and patched. But we see that organizations did not review whether or not they were using that software, did not then roll out those patches that might have been available for months already, and could have then closed that vulnerability.